So when we encounter something that looks like a circle in standard form, a couple of things can go wrong. Let's see examples of them going wrong, and then we'll describe what happened and what we say when that happens. Here we have something that looks like the equation of a circle. X squared plus y squared minus 4x plus 2y plus 5 equals 0. We'd like to write that in center radius form, so we'll start by arranging the terms for completing the square. My x terms, I have x squared minus 4x plus a constant I'll figure out when I complete the square. My y terms, I have a y squared plus 2y plus a constant I'll figure out when I complete the square. And then I'll subtract 5 from both sides. So I'll have a negative 5 on the right. Completing the square for the x terms, I have an x squared, a negative 4x I'm splitting in half, so that'll be 2 negative 2x's. So x minus 2, and then multiplying those I get 4. So I'll add a 4 here. I'll also have to add a 4 here. Completing the square for my y terms, I have a y squared, a 1y here, a 1y here. So y plus 1 plus 1. 1 times 1 is 1. I need the constant 1, which I also need to add on the right. Okay, so the x part of my equation, I get x minus 2 squared. No problem there. The y part of my equation, I get y plus 1 squared. But then when I add up all the numbers on the right-hand side, I get 0. My radius squared is 0. My radius is 0. That's not a circle, is it? The only way this can be true is if we're right at that point at the center. If x is 2 and y is negative 1, because if we actually plug that in, 2 minus 2 squared plus negative 1 plus 1 squared, that's 0 plus 0 really is 0. But nothing else is going to work. If I put in any other numbers for x and y, I'm going to get something bigger than 0. The graph of this equation is just a single point. We call this a degenerate circle. If you'll recall, we talked about degenerate triangles, where it was really just a line segment with a point on it. A quote-unquote circle with radius 0 does some of the things that circles do, but it's really just a point. You wouldn't call it a circle if you met it in the wild. So there is a solution to this equation. This equation means something, but you probably wouldn't call it a circle. Let's see an example where things are even worse. So here's another circle in standard form, and I'm going to start just the same way. Collecting the x terms with space for a constant. Collecting the y terms with space for a constant. And then I'll subtract my 45 from both sides. And then my constant 45, I'll subtract that on both sides. And I'll have a negative 45 here. Okay, now I'm going to fill in the constants by completing the square. So completing the square for my x terms, I have an x squared. Then I have a negative 8x that I'm splitting in half. Negative 4x here, and negative 4x here. Factor out the x. What's left here is a negative 4, and here a negative 4 as well. Multiply those together and we have a 16. We'll have to add a 16 to both sides. Now we'll complete the square for our y terms. We have a y squared, a 10y that we're splitting in half, then we'll have a y times y, a plus 5 is what's left here, a plus 5 here, multiply those together and we get 25. So 25 there. We also need to add 25 on the right. Okay, so far so good. What happens when we go through and add all of those up though? On the left we have x minus 4 squared, that's fine. And then we have y plus 5 squared, that's fine. But when we add up all those numbers on the right, we get a negative 4. In this equation, we have that r squared is negative 4. But that can't happen because our radius has to be a real number. If instead we get that r squared is a negative number, well then there's no way we can add together two positive things and get negative 4. So this equation has no solutions. What we say in this case is that there is no such circle.